Good morning, afternoon, or evening. This is Mr. Chai, and the objective of this video is to teach you about speed and velocity. Before we can learn about speed, we first have to learn about the two vocabulary terms that make up speed. Let's start with distance. Distance is the length of space between 2 points. If you see something that says how far, for example, how far is Chicago, that question is asking for a distance measurement. If it says how long is the table, the words how long have given me a clue that this question is asking for a length measurement. You can also identify distance and length measurements by looking at units. Commonly used units for distance and length are miles, inches, and feet. In physics, we use the metric system, and so our common units will be meters, kilometers, centimeters, and millimeters. The most common unit in physics is meter. My suggestion is to make sure you memorize these because you're going to see these a lot on upcoming assessments. Our next vocabulary term is time. Time is a really difficult word to define, but you can often identify a time measurement if it was measured with a clock or a timer. Let's do the same thing. Let's look at some keywords that would help you identify that a question is asking for a time measurement. If it says, how long does it take? That's asking for a time measurement. Or if it says how much time did it take, that is definitely a time measurement. Units that we're going to use to measure time are seconds, minutes, hours, days, years, and we could definitely go on. We could go on till the end of time. Our most commonly used unit in physics will be seconds. Again, I would make sure you memorize these units because you're going to see these on assessments. Now let's get into speed and velocity. Speed and velocity are measurements of how fast an object is moving. We need to make sure we're including the two vocabulary terms that we've already learned about, distance and time. To better define speed and velocity, you might say it is a measure of the distance traveled in a given amount of time. If you were to put it into an equation form, velocity is equal to distance divided by time. Keywords that you should look for if you want to know that a question is asking for a speed or velocity measurement are how fast is an object going, or what is a runner's speed? What is an object's speed? If we want to be technical, speed and velocity are different. Speed is how fast something is going, and velocity is speed with direction. But for the purposes of this conceptual physics class, we'll just use them as the same word. Speed and velocity for this class are the same thing. Let's look at some units. Notice that every single unit is a unit of distance that we studied on the distance slide per unit of time that we studied on the time slide. For example, meter is a unit of distance, second is a measure of time, meters per second is a measure of speed. Miles per hour is also a commonly used measure of speed, with miles being our distance unit and hour being our time unit. And the same thing with kilometers per hour. It is a unit of distance per unit of time. That slash right there means per or for every. This just means that the speed and velocity describe how far something travels per given amount of time. That's just like what we said earlier in our definition. Let's practice calculating velocity. The question is asking how fast am I traveling if it takes me 2 hours to drive to Iowa City, which is 120 miles away. Let's use the guess method. Let's start by finding the given information. It says that it takes 2 hours to drive there, and it says that it's 120 miles away. I'm going to write down the given information. The distance is 120 miles, and I know that's a distance because of the unit miles, and it says it takes 2 hours to get there, and I remember that hour is a unit of time, so that is a time measurement. My unknown is velocity, and I know that because it's asking how fast am I going. The equation that's going to relate distance, time, and velocity is the equation that was given earlier in this presentation. Velocity equals distance divided by time. I'm going to plug in the given information into the equation. Velocity equals distance is 120 miles divided by time is 2 hours. If you divide 120 by 2, you would come up with 60. Since I divided miles by hours, my unit would be miles per hour. Let's go through an example of how to calculate distance. The example problem reads, if I run with an average speed of 6.72 miles per hour for 1.95 hours, how far did I go? Let's start by identifying the given information. It reads that the speed is 6.72 miles per hour and that it takes the runner 1.95 hours to complete their race. The given information that I'm going to write down is that the speed is 6.72 miles per hour, so I'm going to write v equals 6.72. And it says 1.95 hours. I know that that's a measurement of time because the unit is hours. The unknown is a distance because it's asking how far did I go. The equation is still velocity equals distance divided by time. And this time I'm going to have to do a little algebra. I'm going to plug in 6.72 on the left side of the equation where it asks to put in a velocity. D this time is in my variable, so I'm going to write just D. And on the bottom where it asks for the time measurement, I write 1.95 hours. This time I have to do a little bit of algebra. I want to get D all by itself, which means I have to get rid of 1.95 hours. Right now I'm dividing by 1.95 hours, so I'm going to do the opposite of that. I'm going to multiply by 1.95 hours, which means I have to multiply by 1.95 hours on the other side. If we simplify, D divided by 1.95 times 1.95, those will cancel out, and we're going to be left with just D. And on the left side, we take 1.95 hours times 6.72 miles per hour. You type 1.95 times 6.72 into the calculator, and you get 13.1 miles. And that's a pretty reasonable answer for any runner. Any runner knows that that is a half marathon. Let's also go through an example of how to calculate time. The problem reads, if a track runner is able to sprint at an average speed of 8.7 meters per second, how long will it take them to run 100 meters? The given information is that the speed is 8.7 meters per second. Again, notice it says average speed. That doesn't mean they're going that speed the whole time, but that's their average for their whole race. And they're gonna go 100 meters. The fact that it says meters tells me that that is a distance measurement. So for my given information, I'm going to write down the speed is 8.7 meters per second. And since it's meters, it's a distance of 100 meters. It says how long will it take, which means it's asking for a time measurement. Time is my unknown variable in this problem. The equation is still velocity equals distance divided by time. So let's plug in our information that's given to us into the equation. On the left side, we have a speed of 8.7 meters per second equals, on the right side, the distance on top is 100 meters, and the unknown is time, which is on the bottom. 100 divided by an unknown number is 8.7. I don't like having an unknown in the denominator, so I'm going to get rid of that. Since I'm dividing by t, I'm going to do the opposite. I'm going to multiply by t. I have to, of course, do that on both sides. Let's simplify. On the left side, it's going to be t times 8.7. And on the right side, since 100 divided by t times t, those will cancel out. And we're going to be left with just 100 meters. Now I want to get rid of the 8.7 so that t is all by itself. Right now I'm multiplying by 8.7, so I'm going to divide by 8.7 meters per second. Of course, I need to do the same thing on the right side. Once again, let's simplify. 8.7 times t divided by 8.7, those will cancel out. We'll be left with t equals, on the right side, 100 divided by 8.7 is 11.49 seconds. You can always check your answer by plugging this into the original equation. Originally, we said that 100 divided by an unknown number is 8.7. So test it out in a calculator. 100 divided by our answer, 11.49. We know we've done it correctly if that is equal to 8.7, which it is. Nice job. Hope you've learned something about distance, time, velocity, and speed, and I hope you have a wonderful day.